Hello, everyone. Welcome to our webinar today, Best Practices in Embedded Thin Brick. I'm John Ricco, APA Executive Director. Thank you all for attending today. I thank our presenter for being here to provide this great educational opportunity. And before we begin, I would just like to go through a few announcements of information about the APA and upcoming events. We have our annual convention coming up in October in Delray Beach, Florida. We've got a great educational program lined up, and we'll be down there at the beautiful Opal Grand Resort. Some of the educational content that the committee has put together. We have a leadership seminar, 10 rules for leaders that will change your life and business. And then the remainder of the content is going to be exclusively project management and precast related. We've got a great panel discussion where we'll have best practices in project management. So we'll have some APA members, project managers there to talk about the way that they make sure that things get done right. And then we'll also have a good session. It might actually even be two on creating efficiencies and economies of scale. So how to establish processes to create drawings and shop tickets as efficiently as possible. We know something that a lot of plants struggle with. So we've got some great educational content coming up there in the fall. In addition to that, just to kind of get your head around what's going on in 2024, we're putting on a ultra high performance concrete spring workshop in the Tacoma, Washington area. And we'll be out there in Tim McGordy's new plant, brand new precast plant that he's got up and operational out there. And it will be exclusively on UHPC. We'll be having a hands-on segment in the plant for half a day. We'll be doing some education offsite and some classroom type stuff. So it should be a great event for all of you. So please be thinking about that. The next webinar that we've got coming up on the horizon is creating high visual impact concrete with architectural formal lease agents. So Jim Renda with Crescent Chemical will be presenting that one. And then we also have a couple of other ones just to be thinking about in the future. We've got managing air and concrete in October. And then concrete staining the managing air and concrete is in October, and transformational power of concrete stain in November. One other thing I'd like to point out, if you're not familiar with it, the APA has a great cost-saving program for office supplies through ODP, which is Office Depot's business-to-business channel. Great savings, a great opportunity. So if you're not partaking in that program, I'd encourage you to check it out. There's some significant savings that many APA members are achieving by participating in that program. And then finally, we know there's many of you out there trying to obtain your CE units. There's a number of ways to do that. So this slide might not be the most visible, but we've been sending it out to plants recently just to better inform folks of all the various ways that there are to obtain continuing education if you are an APA certified personnel who needs those credits. So with that, we will go ahead and jump into our webinar. And what I'm going to do right now is bring Steve Kegley up with Endicott Thin Brick and give a brief introduction. Before I do that, I'll just let you know that those of you who are logged into YouTube can submit questions directly through the YouTube chat function. And if not, a pop-up will be happening intermittently with an address where you can email questions in if you are not logged into a YouTube account. So with that, Steve Kegley is with Endicott Brick. He's currently responsible for architectural sales in the southern US and Ohio. He has over 30 years experience in architectural materials and systems industry. And he has served as a building envelope consultant to architects, construction managers, owner developers in the development of both field applied and panelized building envelope systems. In addition, he's AIA certified to provide professional education. He's completed LEED AP certification training and serves on the GCPCI Marketing Committee and the Manual 122 Task Force for PCI, and participates in most precast and tilt-up conference functions in the U.S. So with that, Steve, I welcome you. I appreciate you being here, and I am going to turn things over to you.
Thank you very much. It's great to be with you today. I appreciate the opportunity to do this for you. And hopefully you'll come away with several best practices that you can use on a regular basis at the plant when using embedded thin brick veneer. A lot of you know Endicott. I've been to a lot of your conferences and meetings and things. always enjoy those, and looking forward to Delray Beach for sure this year. But if you're not familiar with Endicott, I read an article about 2 years ago, a masonry magazine out of the Northeast, and we found out in that article that the industry recognized Endicott as the pioneer in embedded thin brick. So just a little quick video that we've put together since then.
Endicott is a 100-year-old internationally recognized architectural brick and thin brick manufacturer. We are the pioneer of embedded thin brick in the precast industry, and we continue to lead the way today by investing in plant expansions and technology to better our product lines and service to our customers. From building a new kiln in 2016 to a new production line dedicated to thin brick corners, edge caps, and special shapes, Endicott demonstrates its commitment to your industry. Endicott Thin Brick meets and exceeds all guidelines of the Precast Pre-Stressed Concrete Institute. We honor our partnerships with producer members and value the architectural vision in creating outstanding projects. With design demands constantly changing, Endicott continues to pioneer new advances in textures, sizes, and colors.
So dating back to 1979 was the first time that Endicott and a precast producer worked together on a project. And one of the engineers at Endicott was a structural engineer and felt like that was something that could be achieved pretty easily. And of course, the precast producer was like, I don't think so. But anyway, they got it all worked out, and here we are in 2023, and we've learned a lot. Gained a lot of experience over the years manufacturing thin brick. And for those of you that are familiar with brick or not familiar with brick, we actually just take dirt out of the ground, mix it with some water, put some additives into it, change the temperature on to make different colors and things, and we create brick. And the brick that you see in some of these photographs have been manufactured for 50, 60, 70 years. Some of them are fairly new. But this slide right here kind of gives you an idea of how long brick has been around. Just for those of you that don't know that, we're approaching 5,000 years now, and it's a product that's very well liked. It's very well used across the entire world. And we used to do surveys back in the 80s, and people we'd get about 80% of the people would say, I want brick on my building. So they don't say that as much today, but that's okay. So we're going to talk about thin brick today, embedded in precast. Thin brick has become the new paradigm for clay masonry, especially in embedded precast applications. When I go to your meetings, when I go to PCI meetings, and the statistics are put up for us to see about how large your industry has gotten, how diversified your industry has become, and all of the different branches of construction, the different types of construction that you're in, and the growth rate is phenomenal. So anytime you use Endicott, we appreciate that. And we look forward to doing a lot of projects with you. So here's a nice project that was done out in the Midwest. Got some awards out that way. And what's interesting, you don't realize that's a Roman sized brick. So that's an old Frank Lloyd Wright 1 5/8 by 11 5/8 that's being used in the marketplace again today. And there's a lot of different manufacturers and a lot of different brick folks that offer thin brick now for you. There's a lot of different sizes. Some of these sizes are more typical to Endicott. There's a lot of different corners, different sizes of corners. There's different types of shapes and edge caps and things. And this doesn't even show special shapes. You can do special shapes with precast just like you can do with any other brick. You might have to modify a little bit on the design side of it, but it can be done. And the reason I wanted to put this up is one of the first best practices that you want to have as a producer member is when you're ordering your material, when you're taking your project off and you're getting ready to place the order, be very specific as to what you want, because the plants, they look at your purchase order and that's what they're going to make. And that's how many they're going to make. And that's the color they're going to make and the texture they're going to make. And I think you need to be very specific and do a good takeoff. Because if you go back to that first slide with that dirt back there in that pit, this is just raw material out of the earth. Okay, it's not refined or anything, and we get variations as brick manufacturers, which we'll get into after a while a little bit more, but in detail. But we get variations in the shade, not necessarily the color, but the shade of the brick. And it may be 2 or 3 shades. It could be 4 shades. And that's just the way brick is. That's the way brick's been for 5,000 years. And that's the way brick's going to be until the end of time. So just be very specific and make sure that your takeoff, you order enough material, and always allow industry standard for brick is about 5%. Okay. If you're getting into something really unique or special or something, you might want to fudge a little bit and get a few more pieces than what you actually need just in case. But a good practice there is to make sure you order enough. Okay. So next thing we're going to look at is, well, how do we get thin brick? Okay. Well, there's only 2 ways to do that. You can make a regular face brick on the left. You can saw cut the face off of it. It's a little costly. It can be quite a process. And it when they run that saw blade through there, that diamond blade, it does interrupt the molecular fusion of clay. Now, I'm not going to get into ceramic engineering today because that's not what I do. But I can tell you I've talked to many ceramic engineers and asked them to explain this, and it is real. Okay. The other way, other than to take a face brick and saw cut a 1/2 inch off the front of it, is to extrude it as a thin brick or a tile. You might think of it as, it looks kind of like a tile in that regards, but uses a lot less energy, a lot less material. It's a more environmentally friendly product, and boy, we could go down that one road big time. But these are the only 2 ways. So here's a quick little video, kind of give you an idea how quick it happens. So just a quick little introduction there on how brick are manufactured. And I'll throw a plug in for Endicott right here. If any of you would ever like to come to the plant and see how thin brick are manufactured, as you notice, the plant looks a lot different today than it did 50 years ago when there were bodies running around everywhere doing multiple things every day. And even the plants today have sometimes 200 or 300 employees. But there's a lot of automation, a lot of technology in brick making today. And so we've come a long way. But I wanted to show you this chart right here for saw cut thin brick. Theoretically, what you're dealing with is a regular face brick that is designed to meet ASTM C216 specifications. Now, the BIA, the Brick Industry Association, they are also the monitor for field applied material, thin brick. And you can see in this chart, they classify theirs as TBS, which is thin brick standard, just like face brick, and then thin brick excellent, which is just like FBX face brick, which is excellent dimensions. You can see, however, under ASTM C1088 for field applied material, their variation in the length of a modular brick can be as much as 1/2 inch. In a TBS, a standard brick, something like you might use on a home or a church or something like that, that type of brick can have a variation of 1/2 inch, plus or minus 1/4. If you go to the tighter specifications, it's plus or minus 5/32, which is still 10/32 of an inch that you can have a variation in there. Now, that's very common in face brick, okay? That's very common. But what manufacturers are doing today is they're buying grinding systems and things to grind that down for you. So that's another process another step in the process that they have to do to be able to supply your order for you. But so let's look at some industry standards for embedded thin brick. And the first one is that thin brick can be about a 1/2 inch thick minimum, really no more than 1 inch thick. As I mentioned to you, there's the face size. There's all kinds of sizes of thin brick out there now. And it just depends on what the architect's designing and what style the building is and things like that, what they use, the type of building it might be. But there's a lot of things out there for them to pick from now. All these special shapes we've seen, corners, edge caps, things like that. The main thing, or one of the key things about thin brick, is that bond between that concrete that goes in there, that back surface of the thin brick has to be distressed. Okay, it can be scored, combed, wire, roughened, ribbed, key-backed, dovetailed, all those kinds of things. And to make sure that the brick and the concrete bond together properly, there's an avenue there for them to bond together. And we all know about dimensional tolerances. That's the big buzz. That's the big talk. And when we look at the PCI specifications, which I think all of you folks there follow along that as well, you're looking at +0 -1/16 for an 8-inch long product, +0 -3/32 for anything over 8 inches. And we're talking about utility size brick, king size brick, meridian size brick. I just keep going down the list out to 15, 16, 18, 20 inches that are out on the marketplace today. We even have companies coming into the United States from Europe with 22, 24, 26 inch stuff. And I can assure you that my time in the brick industry, which is around 30 years now, being with manufacturers the whole time, it gets very, very difficult to make a brick that's within a 1/16 of an inch in any direction in those kind of lengths. But it's out there today. Okay, just want to let you know that. So we're going to talk about warpage and bowing. We'll get a little bit more specifics here on that. Talking about being out of square, that's more in reference to the corners and things like that. Flats, typical thin brick flats are the way they're made and everything. They're perfectly fine in terms of square. And then shapes and stuff like that, we're talking about 1 degree plus or minus. But we'll get into that just a little bit. So how does thin brick comply with PCI? Okay, this is very typical for anybody, anywhere, anytime when they want to measure a brick. Okay, they put it on a table to see if it's flat. Or they lay them back to back. Sometimes they don't even take them out of the packing and they lay them back to back like that so that they can see if they're warped or bowed. And that is not the way to do this. So, excuse me, right off the bat, best practice here is to buy you, or we can send you one of these little wedges right here that are precisely measured off in 1/32 of an inch. You can see the black mark there is in between those two lines. That is 1/16 of an inch. That's within specification. Okay, you measure it on the ends, you measure it in the middle, like that right there. Then you lay it down on its belly and you do the same thing to see if it's within a 1/16 of an inch, which is the specification. You don't take tape measures or anything like that. You don't set it on a table. You don't use squares, carpenter squares. You do it with precision tools and things like that, which we'll talk about. And these are available in the marketplace. Everything on here today we're going to talk about is available to you. So that's a great thing when you get an order in. Just pull some random samples and just make sure that everything works. Throw those in the form liner and make sure that everything's going to fit, so on and so forth. All right, sizing can be a problem for you. So this is another best practice. When this is magnified, by the way, as you can tell, I've zoomed right in on this right here, but that's only about a 32nd of an inch gap. All right, but we know how concrete runs, and we know how that face coat can run, and that can get down around there, which is why we most of us wax the front of the brick to protect it from any spillage. But the sizing can be an issue, or it can cause an issue if it's not right here, like it is in this photograph. Okay, and when orders come in and they get manufactured, I don't know of a thin brick company that doesn't work with the form liner, provide them a sample so that they can match up the thin brick out of the run maybe 24, 30 pieces with their form liner, make sure everything's right. And you should do that as a best practice. You should make sure that when you get the form liner in and you get the thin brick into your plants, that you're measuring them, making sure they're the right length and the right height, and making sure they match up properly so that they can just stick them in there and they fit nice and snug. You can see with a digital caliber here, which is very precise, we can get this, we can actually set that to go to 1/1000th of an inch if we want to. We don't have to do that, but your panels are precise, your engineering is precise, the products you use need to be precise. And this is a perfect match, just so happens, between a plastic form liner and a thin brick. So we hope they all work out that way, but we all know they don't. Okay. Same thing on corners. A good practice for corners is to get you a digital protractor. They have them all kinds, all sizes and everything. And you can measure those corners. If you pick it up and look at it and you think there's something wrong with it, it doesn't look right, then put a digital protractor on it. If it's not right, any of these thin brick that you find something wrong with when you're measuring it and such, just set it off to the side on a pallet, hold on to it. Manufacturers will help replace those. Okay. It's not a big thing. We can't make exactly what you order at the plant. If you order 11,000 square feet of modular size brick, we're probably going to have a few thousand square feet left over because we can't control it that way. Okay. But so if you go back to the plant, they use this digital protractor right here to set the gauges for a PCI job or a precast job. And then those gauges are made out of steel. So once they're cut out, set up, and they show 90 degrees, that's what we go by. And they have a mark to the left and a mark to the right for 1 degree. And when they pull out two corners and they set them in that gauge, if they don't work, they go to a pallet that says they're not PCI compliant. They don't just stick them in the pallet and package it, hoping that it works okay for you. Because we know it's not. We've been to a lot of jobs, been to a lot of precast plants. We know that it doesn't work, so we're going to set it aside. Same thing with flats. And I've had a lot of architects. We do an AIA continuing education course in support of precast. Endicott does, and we've given this thing between the five of us probably 100 times. And we explain to architects these tolerances about warpage and bowing and lengths and things like that. And we try to explain to them, you need to try to work with the precaster and make sure that they're telling you what they would like to have in terms of a dimension. So what? It moves at 2 inches or it moves at 1 inch or what from standard, 24 feet or whatever, but that's okay. If it works better for you as a precaster, we think that's the way to go. So like I show them this example. Here's a 24-foot tall panel. It's on a school out in the Midwest. It's modular size thin brick. There's 110 courses. If those brick come to the form liner at the precaster's plant and they are 1/16 of an inch too tall, we're almost 7 inches off with the brick. Or if the form liner's off and they don't fit in there, there's a couple of things that can happen there that you have to deal with. So it becomes a big deal for them to grasp that and understand that they need to make sure they work with the precaster. And obviously you guys like to work with them and try to keep them out of trouble as well. So then we jump kind of to the second half of the specification that sometimes gets ignored. There's a lot of conversation and a lot of things done, for the dimensional tolerances, and that's all great. That's good. But a lot of people forget about that bottom section right here, or the next section. We're talking about properties, and that's breaking strength that cannot be less than 250 PSI. That's the thin brick itself, not the panel. And then the cold water absorption, a maximum of 6% at 24 hours. Now, that's not a number that came from the brick manufacturers. That's a number that came from your engineering department. At the national level, know everything about precast. They said that's where the thin brick need to be, is 6%. They also are familiar with efflorescence, and that is you are putting a clay product into a concrete product. And efflorescence comes from the salts in the concrete getting wet and migrating to the face of the wall and with water vapor, air vapor, whatever. And then when it stops, when it gets to the surface of the brick, it stops. And then the air evaporates out into the air. Well, it leaves those salts on the face of the brick. And regardless of what color the brick is, red, brown, tan, black, whatever, doesn't matter, it's going to show up as white. The only time you're not going to see efflorescence, and you're still going to see it, is on a white brick, because you're going to see something else besides efflorescence on a white brick. But freeze-thaw resistance, very critical. Northern United States, Southern United States, not such a big deal. That's on uncoated and surface colored brick, okay? And then the pull-out strength is critical that people need to understand. And we talked to architects about this as well. But the chemical resistance, nothing can affect, the thin brick or the precast. It can't be affected that way. Now, testing requirements, these last two things here. The letter of certification from brick manufacturer should be provided. And a best practice there, I think, for you as a precast producer is to make sure that on every single job you use thin brick, whether it's PCI compliant or not, you have a letter from that manufacturer explaining why they don't meet PCI and the test reports, or why you do meet PCI specifications and the test reports. Anybody that's not willing to do that, you might want to reconsider what the product is that you're using. And again, the back surface texture should be the same on all the samples that are used when they're doing the testing. And you'll see some testing that we've done that I thought I'd throw in here for you to understand, say a little bit more about that. But that maximum cold water absorption rate is measured by weight. And when I mentioned to you that a face brick is an extruded brick, just like an extruded thin brick is, except they saw the face off of it and disrupt the makeup of the brick when they're making thin brick out of it. We do samples in the industry every day, just exactly like that, but they're just samples. They're just going on a sample board, okay? So that maximum absorption rate of 6%, because the body of the material is disturbed by that saw blade and it leaves an open surface there is an increased possibility that it might have an issue going into the precast into a certain market. Okay, so that thin brick, that bond between that thin brick and that concrete is critical. And most modular size thin brick, I have never done a math for utility size or the big 16s, but I would say anywhere between 57 and 70 or 57 and 59% of the brick is embedded in concrete. So it's a critical factor. And this, I just asked the sample department to lay some backside brick out for a sample board, just so you can kind of see what I'm talking about. You see how smooth that is? So just make sure that whatever product you're using, whatever specified, you get a letter of conformance, letter of certification, whatever you want to refer to it as, from the supplier, from the manufacturer, so that you do get that information, have it in your files, okay? Pass it along to the GC as well. Don't just hold on to it. So this was some testing that we did at Endicott a couple of years back. We took our key back, we took our rib back. And by the way, Endicott has, because of these testing, has decided, and recovery rates, we've decided to go to a rib back all the time on flats now. So we're hoping that works out well. We've been doing it with corners for years, and we just feel like it's a better deal. But so what they do is they take these thin brick, they embed it in concrete. You can see the photographs down here, and then they run it. They do all the measuring on the first line there, the top line, when it comes in right out of the pack, and they do all of that testing on. Then they run it through 300 cycles of freeze thaw. Okay, so 300 cycles to make sure that's the testing requirements. And you can see that the pull-out strength is 290 before they put it in the concrete and tested it. It was still 216 after the fact. Now their code, the specification calls for 150 for pull-out. So we're exceeding either one of those or in either application there. Then we took some of our brick and we just saw cut the face off of them, the regular extruded face brick. And you can see what happened to the delamination in the pictures there. 2 of the samples, there was nothing left to test after the 300 freeze-thaw cycles. And most of what you see, everything failed. So we know that the water absorption and that, from our own experience, is something to take into consideration when you're looking at thin brick material for embedding. Okay. Here's kind of just a copy, which is, I mentioned to you, the letter of conformance, letter of certification. This is kind of an updated version of it that's being looked at right now for final approval. But it's very specific. You know, your job is, all of your contracts, all your job and everything, all your documentation is specific, and make sure that the thin brick that you're using is, all of that documentation is specific as well. So another thing, and I was going to come back to this, I mentioned it earlier, that raw material, the way that comes out, when brick are made, they're put on a dryer car. And that dryer car, I'm going to guess, is about 15, 16 feet square. And there's anywhere from, in a thin brick application, there's anywhere from, so I don't know, probably 5,000 square feet on a car. So there's a lot of material on a car, and it's all based on tonnage. Now, that car being 16 feet wide, it has a temperature right at the outside edge of the car. As it moves into the car from the top down through the car, things change. That's where the range I mentioned to you earlier comes from. So at the plant, a best practice that we use is we blend the brick multiple times before we put it in the pack. Then each pallet has a tag on it when it comes to you at your plant, and it recommends that you, again, best practice, work out of multiple cubes to continuously blend the brick. It's not hard to do in most situations, but that way, if you have a project, and this is a gantry system that we use, this gentleman that operates this, you might have seen him in the video there a while ago. He has like a little Game Boy device. He has 64 stacks of brick to pick from, and he does it just randomly. He just walks around all day doing it, to pick from, to put them into the product line to start the blending process. This is right after they've come out of the kiln, and that's the first thing they do with them. And then it's a combination of belts and things like that continually blend it. But when you have a project like this, when you have a stadium that has over 1 million pieces of thin brick in it, you don't want, especially in a panelized application like precast, you don't want to get a hot box or a hot spot where one panel looks completely different from everything else, because I can assure you that those brick are blended at the plants before you get them. And the manufacturers that make thin brick, we have no idea where you're putting those brick. We have no idea what panels are going into. We just blend them, do our regular quality control process, and then send them to you. So if you guys are blending them, and gals, if you're blending them at your plant, we're pretty sure that you're not going to get a hot spot in the wall somewhere. So, and that's an easy thing to do. And then we talk real quick about the different types of form liners that are out there today. And there's probably 5 or 6 manufacturers in the country that you would deal with, whether it be plastic or rubber. And all of these have to be PCI compliant to those dimensional tolerances, just exactly like the thin brick do. Okay. They can't just make them any way they want to and then go from there. So choose the appropriate form liner for the type of application you're doing. And you guys know how to do that better than we do, but we just put it in there. We do talk to architects about this a little bit so that we can always have them have an understanding of how you guys operate. So when you take a form liner, plastic or rubber, that allows you to do architectural features like this is multiple sizes of brick, multiple textures of brick, multiple thicknesses of brick, and architects cannot do this with face brick. So I call this a best practice of selling and marketing. Talk to them about stuff like this. Don't just let them do a plain old flat wall. Okay. If they want to do something architectural and it's not crazy out of budget, talk to them about it. Show it to them. We can provide pictures, all of us, of jobs across the country that you've done that are just gorgeous and very architectural. This is a really neat project. It's at a university in the Northwest. And I asked, surely they started this on the 3rd or 4th floor of that building, because can you imagine Friday night after finals, maybe a drink or two, and these kids are trying to see who can climb to the top of the building on this one. And this one I call the Wave. This is pretty cool. I found this picture online and did some research. So this building has movement in it as you go around the building, and it's the Formliner. You can see it on the left there. So Formliner technologies have significantly advanced in the last 10 or 15 years, and they want to try to keep up with the precast guys. So when we look at precast production, this is a tag that Endicott puts on every single pallet that goes out of the plant. And we put it in the submittals. We put it in your price quote. We want to make sure that you see it, because these are some best practices in the plant that will help you significantly. So most of the time when we sell a thin brick job for precast, they ask us to wax it. So we do. We use a real inexpensive paraffin wax. It's very thin. It's just enough to cover the face of the material, the brick, to prevent the concrete and face coat from sticking on there. If you don't store this material properly, and by the way, once you receive the material and sign off on it, it's yours. So it's your responsibility to store it correctly so that you keep it away from the sun, direct sun, and you keep it away from high heat levels. Just the opposite in the wintertime. You can't let it sit out in the freezing cold. You can't let it sit out in the snow and things like that either. Okay, because that has an impact on the wax too. It's not that thick. It's not that big, huge, 1/4-inch stuff. So, but this can happen right here. And then when you open up your packs to go put them in the Formliner, you're going to see this, or they may not see this, or they may not care and just put it in there. And then you might have some issues getting the material, the overflow on there. Now, some Formliners require a retarding agent or a releasing agent. And you can see in this picture that it's quite clear where it was. Okay. And that's an issue that a best practice there would be if you have a Formliner that requires that, make sure that you test it with the brick. Make sure that you test everything before you ever start, and make sure everything works together so that when you get done with the panel and you go to the cleaning process, you don't have to go to extra cleaning and stuff like that to try to get material off of there. One of the other items on there, best practice, we've already touched on it, is blending from multiple pallets. You get a pallet, it's got 300-400 square feet of material on it. It's easy to bring 4 or 5 pallets in and work out of 4 or 5 pallets at a time. We tell masons every day in brick veneer, work out of 3 or 4 or 5 pallets, okay? As much as you can to try to create that blend, create that nice architectural feature. And I know nobody at your plant does this, okay? And nobody at Endicott's plant makes any mistakes or does anything crazy either. But looks like a 16-inch brick based on the size of his foot, and he's standing right in the middle of it, okay? The chances of him cracking that brick at 230 pounds is probably pretty good, okay? Just walking around like that. You can go to Home Depot and Lowe's. You can buy rubber mats. You can go to Ollie's or anywhere like that. You can buy rubber mats to throw over top of this stuff. Lightweight, inexpensive to step on, okay, while they're putting the rest of the brick down. Things like that. It's not an expensive thing. Great practice to prevent that, because what's going to happen is he may slightly crack that, not know it, not see it, not take it out and replace it. Concrete gets poured in there. Now you got to dig it out on the other side. After you clean it, you got to dig it all out and epoxy a piece back in there and all that. All of you had to do things like that from time to time. So that's a good best practice. Then we get towards the finish here, and we talk about cleaning brick. This is the most important thing you do. Period. Your panel is not sold on the back side. Your panel is sold on the aesthetics. It's an architectural thin brick precast panel. They're not looking at the concrete. They're looking at the brick, the thin brick. This is the most important step to making it look good. That wax easily removed with hot water at the tip, 180 degrees, with a low pressure washer of maybe 1200 psi. And you can test this in a bucket. You can do however you like to do whatever is the easiest for everybody. But you can certainly do this and make sure that you get that wax off of there, and you don't, they don't need to get the tip right on the wall and things like that. You're using a lot more sand coated brick today than we used to use and things. So you don't want to cut into that and get into the body of the brick. You also want to make sure that that wall is just saturated with water, just good, clean water that's not got all kinds of trash and stuff in it and impurities and things like that. And you've got to start at the top, and you've got to keep a 4 or 5 foot section, and you got to work it all the way down the bottom with clean water. You can't just go back and forth and let it dry and things like that. And one of the coolest things as a best practice is make sure you do a test before you ever get into your panels. Make sure you do a test to make sure that the chemicals you're using are correct. Make sure that everything washes off properly and it looks nice when they're done. The use of muriatic acid or unapproved cleaning agents is not a good practice. Okay. And I know that in our construction industry for years and years and years, we've used muriatic acid or sulfuric acid that does a great job cleaning and creates all kinds of cool textures that you all have in the precast world when you're not using thin brick, and they look awesome. But for this application, there are chemical companies that have tested thin brick products across the country with their product, and they will give you the test reports, and they will show you that this is an acceptable product to clean this particular type of brick. And at Endicott, we provide that information as part of the submittal package and the price quote as well. So that's all included from us. You don't have to worry about that. Proseco is one, EcoChem is another. But we've done tests at the plant in the lab with concrete embedded thin brick in concrete, and they've played around with the different percentages of acid, and it can do some major damage. And it's not just to the brick. It gets into the concrete. Believe it or not, it will get into the concrete, and it can cause some major issues in there it is very eye-opening. So please use approved cleaning agents. And today, architects love architectural design, so they like colored mortar. They like to get really fancy with colored mortar. And you can see here, this is a black mortar project with a black brick. And because it wasn't cleaned properly, you've got this collection of mortar pigment or face coat pigment that's set or came out to the edges of the brick and dried. Okay. And once it dries, it's hard to get off. And I can tell you that there's a famous phrase that I've ran into multiple times in my 14 or 15 years of dealing in embedded thin brick. They say that this brick is leaching something, manganese, red iron oxide, whatever it is, based on the color or whatever. People say it's leaching. Well, I'll explain to you real quick. Brick is fired anywhere from 1,500 degrees Fahrenheit up. Okay. I'm pretty sure that to undo the ceramic configuration of a brick, you would have to be hotter than what it was fired at. And I'm pretty sure we've not ran into any 1,500 degree days yet. So there's no way that that's coming out of the brick. That's coming out of the mortar, the face coat. Again, application here where you can see some of the leftover residue from the retarder or the releasing agent or whatever. And then again, when they cleaned this, they didn't water it all the way down to the bottom of the panel with a lot of water. So therefore it started drying. It must have been done in the summer, spring, fall, or whatever. We can see that it's kind of dried on there. So another best practice is, cleaning that brick thoroughly. Here's an interesting picture because you can see it looks like the brick is just destroyed, but yet look at the mortar joints and the little gaps and the holes in there. This wall has obviously been cleaned with muriatic acid. Maybe it wasn't full strength. Hopefully it wasn't full strength. But like when you're doing your etching and stuff on joints, if you can use a 10 to 12 parts acid to 1 part water to etch your joints, if that works, and leave the wax on there. Do that first and then cut the wax off and really rinse the wall really good. You should end up with a pretty nice looking project. That's a good best practice. And here's a really gorgeous panel from that project you saw at the beginning where it's been cleaned properly. And that's a white mortar with a black brick. which is hard to do, and it looks great. Okay. Then I want to just wrap up right here real quick. This was a neat project that was done out in the Midwest at the University of Minnesota. The two buildings that you're looking at in the foreground were built in 1920. Those are multi-white brick walls, all locked in, structural, load-bearing, the whole deal. And the original, where the courtyard is, there was where some other part of the dormitory was. That had to be torn down. It was not doing well, and they decided to build these new dorms there. Well, all of this is on the National Historical Register. So you can imagine how much fun that was for the precaster to get involved with the National Historical Register. But they did it. They proved it. They used a multicolored blended brick, and it turned out phenomenal. There's a lot of other precast features in here with the 3D printing and things like that. This is a Flemish bond pattern, so you got a full brick, half brick, full brick, half brick, all the way around every course. Multiple colors. This is all the precast portion of the building now that you're seeing right here. And there's a close-up of the two buildings that you saw in the foreground. You can see the color of the brick looks pretty close. Excuse me, there was no way it was going to be exactly perfect. That's okay. It was close enough for the historical people, and turned out to be a pretty nice project. So here is my email and my phone number. If anybody has any questions or wants further discussion, I'll be glad to take your call. Unfortunately, next week I'm going to be on vacation and outside of cell range, and so I won't be able to talk to you next week, but would love to hear from you. Again, like I said, I'll make the offer if you ever want to see a brick plant, thin brick being made. We certainly would invite you to come to Endicott, and we appreciate all of our partners in precast world. Been at it a long time now, and we look forward to doing a lot of projects with you in the future. So thank you very much, and turn it back over to John.
Steve, thank you very much for that presentation. I just checked the email as well as the chat and did not see any questions come up, but let's give folks just a moment or two to see if anything comes in here in the next moment or two. But appreciate you taking the time to do this today, and for sharing your expertise. Let me ask you just a general question is, when you see an issue come up with thin brick, most commonly, what's the issue that pops up?
I would say size most of the time.
Mm-hmm.
If the thing about the guys at the plant are human beings just like us, and they have good days and bad days. And Endicott is very particular about how they grade thin brick material. And as you heard me say, when they're doing corners, they're only looking at 2 brick at a time. Each person only looks at 2 brick at a time. Same thing with flats. They only grade 2 brick at a time. I've been worked for 4 different manufacturers, and sometimes they'll pick up 8 or 9, 10 brick at a time and put them in there, and you're like, well, how did you even know if those were the right size or not? You know, but I think the size issue, because the mining area has been used at Endicott. It's a 102-year-old company. They've been making bricks since 1920. So there's large pits out there that are 70, 80, 100 feet deep, 3 acres. You know, they're big. And so that clay varies. And we have the ability to monitor from time to time. You know, we check it all of the time, really, to make sure that it's maintaining its shrinkage and stuff like that. So, but,
okay.
You know, probably number 2 would be color, I guess. And that depends on who the brick manufacturer is and the clay they're using and so on and so forth.
Mm-hmm. Okay, great. Well, I don't know if you can see this, but it looks like a question pop. Do you fabricate concrete thin brick?
No, we do not. We only manufacture clay. I don't know if concrete would be able to match that 6% absorption rate. I have no idea. It'd be hard.
All right, Melvin, thank you for that question. Appreciate it. If you have a follow-up, please go ahead and put it in the chat, and we'll give you a moment or two to do that if you do. But now, Steve, you'll be joining us down in Delray Beach at the annual convention.
I am planning on it, yes.
Okay, great. So another opportunity for you if you have questions or want to talk to Steve in more detail, opportunity to do that. Hopefully before then, though, if you have a question. All right, let me just run into the emails real quick here and see if anything has come through there. No, nothing in the email. Nothing else in the chat. Well, with that, then, Steve, we'll go ahead and wrap it up. I appreciate very much you being here and sharing your expertise. I know our folks got a lot out of it. In addition to the folks who could view it here live today, this will be on our YouTube channel for people to view in the future. So it'll be there in perpetuity, if you will, for folks to view. So thank you very much and appreciate your time.
Thank you. Appreciate the opportunity. Have a good weekend.
You too.